Okay, so the diagram shows a block A, right, of mass 8 kilograms. So I started to draw this out here, okay. So it's going to be of mass 8 kilograms. So the weight, okay, is going to be hg, right, and that's obviously vertically downwards. Okay, so I can start to fill these forces in here now. On a smooth plane, inclined at an angle of 30, so I've got that to the horizontal. The block is connected to a body B by means of a light inextensible string, right? So you've got this string here, okay, passing over a smooth pulley, okay? So tension, of course, then in the string, pulling up the object, and the tension then is is pulling up object B here as well. And object B is of mass, what have we got, mass 6 kilograms. So we're going to have 6g here, yeah? Now, the reaction between the body A here and the plane needs to be perpendicular to it. And don't forget then to continue, I forgot then, didn't I? Continue that line down, okay, so that the angle here then is going to be the same as the angle there, all right? So we've got a reaction here. Now there's no friction or anything, right, because it's a smooth surface, but we resolve then these forces on the inclined plane. So remember now, if you've got the angle here, this is going to be hg cos 30, right, because that's like the adjacent side, right, with the angle there, and the adjacent is cos, isn't it? The opposite side then, okay, would be sort of opposite side created there, opposite the angle, and that's the sine, isn't it? So then the opposite side is parallel to the plane here, so we'll have the sine component then going this way, okay? You know, once I fill it in now, it's sometimes best to actually turn it around, and you can kind of see then what's going on in terms of resolving forces. Okay, so when you see it sort of vertically, you can see then why that's hg cos 30 and why that's hg sine 30. Okay, or maybe even better if you turn it that way, you might see it better, hg cos 30. If you think of that as like the horizontal then, and that's the vertical, as I turned it around, that's hg cos 30, isn't it? And that's hg sine 30 that way. Okay, so we've got all the forces, I think, in place now, yeah? And in the question itself, it says that initially the system is held and then the system is released. So we're going to have it accelerating like this, okay? Right, because object B is going to pull down and this is going to move up the plane, okay? So if we then use Newton's second law, okay? So we're going to go at A, maybe to start with, yeah? So in the direction of motion, we've got tension pulling it up. Take away then the weight component pulling it down, so hg sine 30, and that will equal then to mass times acceleration 8a. And what's good is sine 30 is just a half, right? So you get t minus 4g equals 8a, okay? So that's one there. At B then, okay, B is even easier to resolve because it's all happening in the vertical plane. So you've got 6g pulling down, take away the tension then, that will equal to 6a. So that's equation 2. All you've got to do then is add them, right? Add them, simultaneous equations 1 and 2, add them and it gets rid of the tensions. So you get 2g, so this 6g add minus 4g is 2g, that will equal to 14a, and you add them. And then a then will equal to, well, 2g is 2 times 9.8, and then take the 14 over and divide, so you get 1.4 meters per second squared. Okay. To get tension then just sub it in. I'd sub it into number 1, right? So sub into 1, t, take away 4 times 9.8 equals to 8 times 1.4. So when you do all the maths there, you get 50.4. Okay. So part B then, it says, what assumption did the word inextensible, underlined above, enable you to make in your solution? Okay, so first of all, the word inextensible, okay, just means that the string, okay, will not stretch, okay, so it can't stretch. It's not like an elastic band, because an elastic band, if you think about it, it stretches quite easily. It won't stretch at all. But if you think about an elastic band, when you stretch an elastic band, right, because it stretches, different parts of the elastic will accelerate at different rates, okay? So maybe in the center it won't accelerate so much, but at the extreme where it's really being expanded, it accelerates a lot more, okay? So that's what happens when you can extend it, okay? But if it's inextensible and it won't stretch, that means the acceleration, okay, is the same throughout the system, okay? Okay, so that's our assumption that essentially then object A and object B accelerate at the same rate, okay, because they're connected by an inextensible string that is taut, so the movement is consistent acceleration throughout.